Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another video on chemical reactions. Today, this is chemical reactions worksheet number 5. And I'm assuming that you have watched all the previous videos in this playlist of chemical reactions in order to actually perform this one. So without further ado, I'm going to zoom in on this and we are going to balance chemical reactions here today. All right, that's our plan here. So here we go. Zooming on in and let's straighten this out here so that we can see everything that's necessary. All right, so this first one here, just as a quick little reminder, we are writing stoichiometric coefficients. Those are numbers in front of formulas that distribute throughout that formula such that we can balance the chemical equation. That is the same number of each element on both the reactant and the product side. What you want to do is imagine this arrow that separates the reactants on the left-hand side of the arrow from the products on the right-hand side of the arrow. You're going to imagine that arrow as an equal sign. So you want the same number of each element on both sides of the chemical reaction. So for example, there are 2 chlorines here on this reactant side, and that's that little subscript 2 there that I've highlighted in yellow. And there's 1 chlorine here. That means that I need to place a 2 coefficient in front of the lithium chloride. That 2 distributes amongst the lithium and the chlorine. So that is 2 lithiums and 2 chlorines. The chlorines are now balanced. If I go back over to the reactant side, you should see that there's 1 lithium on the reactant side and there are 2 lithiums on the product side. So that means I'm going to place a 2 in front of the lithium iodide. And that 2 distributes to the iodine as well. So there are 2 iodines on the reactant side, and there are also 2 iodines on the product side. So this is actually balanced now. This is a single displacement reaction right here on this particular example. All right. So let's move on to problem number 2. Okay, problem number 2 is a combustion reaction. And with combustion reactions, you're always going to balance it in a particular order. That particular order of which is necessary is carbons, hydrogens, and then oxygens, CHO. So you're going to balance it in that order. If you don't balance it in that order, it will take you much longer to balance the chemical equation. All other chemical equations, you're just going to balance it using whatever is the most complicated formula, and that is your starting point. But for a combustion reaction, we're going to balance the carbons, then the hydrogens, then the oxygens in that order. So if we look on the reactant side, there are 7 carbons on the reactant side. There's 1 carbon on the reactants, on the product side, excuse me. So I'm going to place a 7 right here in front of the carbon dioxide. Then there are 16 hydrogens on the reactant side, and there are 2 on the product side. So that means I'm going to place an 8 in front of the water. Okay. This 7 lets us know that there are 7 carbons, and then how many oxygens? So I'm going to write this in pencil here because we have already balanced now the carbons, the hydrogens. Now we need to deal with the oxygen. So to deal with that, what we're going to do is calculate the number of oxygens right here with that stoichiometric coefficient of a 7. So it's 7 times 2, that is 14. And then it is 8 times 1, that is 8. And now what we're going to do is add up these 2 numbers here. That is 14 plus the 8, that is going to equal 22. I need to have, that means there are 22 oxygens on the product side. I need 22 oxygens on the reactant side. So in order to make there to be 22 oxygens on the reactant side, I'm going to place an 11 stoichiometric coefficient in front of the O2. That'll be 11 times 2, that's 22. All right, perfect. Now I balance the oxygens, check, done. All right, Again, that is a combustion reaction. You're going to balance combustion reactions, carbons, hydrogens, then oxygens in that order. The last step that you do for every single balancing equation is you're going to double check that you have balanced it. That is 7 carbons on the reactant side, 7 carbons on the product side, 16 hydrogens on the reactant side, 8 times 2, that's 16 hydrogens on the product side. There are 22 oxygens on the reactant side, and there is 7 times 2, that's 14, plus 8 times 1, that's 8. And so it's 8 plus 14, that's 22. That's 22 oxygens. Boom, you have done it. Congratulations. All right, our next problem here is problem number 3. This is a single displacement reaction, and you get magnesium plus nitric acid produces magnesium nitrate and hydrogen gas. So you generally start with the most complicated formula, and I'm just underlining that right here with the magnesium nitrate. There's 1 magnesium on the product side, 1 on the reactant side. This 2 distributes amongst every element which is inside the parentheses. So that means there are 6 oxygens and 2 nitrogens. There's 1 nitrogen. So I'm going to place a 2 right here in front of the nitric acid. That'll be 2 nitrogens. Then the next element, there are 6 oxygens. That's 2 times 3. There are 2 times 3, 6 oxygens. So the oxygens are balanced. There are 2 hydrogens. There are 2 times 1, that's 2 hydrogens. Checked. That one's balanced as well. Fantastic. All right, let's go for the next problem. The next problem is a double displacement reaction. It's a barium nitrate plus sodium sulfate produces barium sulfate and sodium nitrate. All right, again, we're going to start off with the most complicated formula. That's ideally what we want to do. And either that is the barium nitrate or it's the sodium sulfate, one or the other. There's 1 barium on the reactant side, 1 barium on the product side. There's 2 nitrogens. Remember, this 2 distributes just like it did in problem number 3. That's 2 times 3, that's 6 oxygens, and then 2 times 1, that's 2 nitrogens. On the product side, we have 1 nitrogen, so I'm going to place a 2 right in front of the sodium nitrate. Next element we're going to deal with is the sodium. I'll come back to the oxygens in just a bit here. So there's 2 sodiums on the reactant side, and there's 2 sodiums on the product side. There's 1 sulfur on the reactant side, 1 sulfur on the product side. Now I need to check the oxygens. So let's just make sure. So 2 times 3, that's 6 oxygens plus the 4 that's right there. That's a total of 10 oxygens on the reactant side. Then on the product side, there's 4 oxygens here, plus 2 times 3, that's 6, that's 10 oxygens. Looks like that balances. We are good to go. All right, fantastic. So what we're going to do is we're going to slide this little baby on up here so we can do some more problems. Here we go. Fantastic. There are 19 problems in total on this worksheet here. All right, so the next problem is problem number 5. This is a single displacement reaction where you have calcium metal and aluminum chloride produces aluminum and calcium chloride. All right, so 1 calcium on the reactant side, 1 calcium on the product side, 1 aluminum on the reactant side, 1 aluminum on the product side. 3, I'm going to highlight this here. 3 chlorines on the reactant side and 2 chlorines on the product side. So what's the greatest common factor between 3 and 2? That is 6. So I need 6 chlorines on both sides. That will give me a 2 coefficient in front of the aluminum chloride and a 3 coefficient in front of the calcium chloride. Now, this is why you check your balancing at the end every single time, because why is that? Well, for the simple reason that you most certainly have already balanced the aluminums and the calciums. However, you need to rebalance them. There's 2 aluminums on the reactant side Now there will be two aluminums on the product side. There's three calciums on the product side, and now there will be three calciums on the reactant side. Now it's balanced. Perfect. All right, let's scroll this on up here just a bit. And let's do problem number 6. Problem number 6 is a combination reaction. It's potassium plus oxygen gives me potassium oxide. There's one potassium on the reactant side, two on the product side. There's two oxygens on the reactant side and one oxygen on the product side. So again, one of the things that you cannot do is change formulas. That means I cannot put a little tiny 2 down over here. I can only put stoichiometric coefficients. That's why I'm underlining those, placing those red lines there in front of each one. So there's two oxygens here. I'm going to make there to be two oxygens on the product side. That will give me 2 times 2 potassiums on the product side, and there, so that's 4. And over here on the reactant side, there's one potassium. So I'm going to place a 4, just like that. Okay. Everybody doing good so far? Take a deep breath and keep on going. We don't want to stop here. All right. Fantastic. That one is taken care of. Number 6. Let's go on to number 7. So number 7 is a single displacement reaction where we have fluorine plus potassium chloride produces chlorine and potassium fluoride. That's number 7. There are 2 fluorines on the reactant side. There's 1 fluorine on the product side. So I want to place a 2 coefficient in front of the potassium fluoride. There's 1 potassium on the reactant side, 2 potassiums on the product side. So I'm going to place a 2 in front of the potassium chloride. Now there are 2 chlorines on the reactant side, and whoop, there are 2 chlorines on the product side. That one is balanced. We are good to go. Fantastic. Sliding this up just a little bit here. For our next problem, this is a decomposition reaction for number 8. We have silver oxide produces silver and oxygen. Okay. All right, so there are 2 silvers on the reactant side and 1 silver on the product side. So I'm going to place it 2 right here in front of the silver. And then there's 1 oxygen on the reactant side and 2 oxygens on the product side. So that means I'm going to place a 2 in front here. That would give me 2 oxygens on the reactant side, of which there are 2 on the product side. Now, this is one of the things that you have to understand. This is why I did this in pencil. If you noticed 2 on the silver on the product side, there's 2 times 2 now with this 2 coefficient that I didn't have before, but now it's there. There's 4 silvers, so what we're going to have to do is erase this 2 and replace it with a 4. So this is why it's critical that you just double check that you have balanced it every single time, and there's nothing wrong with that. Okay, so keep on checking your work at the very end. You should understand whether you got the correct answer or the incorrect answer. That should be pretty easy on that. Okay. Next reaction is problem number 9. This is a double displacement reaction whereby magnesium hydroxide reacts with nitric acid to produce magnesium nitrate and water. Okay, this is a common base plus acid gives me a salt and water. Characteristic reaction of a neutralization reaction, actually. All right, so what we're going to do is look at the magnesiums. There's 1 magnesium on the reactant side, and there's 1 magnesium on the product side. Now, it's up to you what you want to do at this point in time, but you should see that we're going to go for an unusual element, and that is this nitrogen. Okay, so but you could go for the oxygens or the hydrogens, but I'm going to go for the nitrogens because that's a little bit unusual. So there are 2 nitrogens on the product side. There's 1 on the reactant side. So I'm going to place a 2 in front of the nitric acid. That would give me 2 nitrogens. Now I'm going to look at the hydrogens and the oxygens. Right here, this 2 distributes amongst the O and the H. So there are 2 oxygens and 2 hydrogens. And right here, there are 2 hydrogens. So that's a total of 4 hydrogens. And that's on the reactant side. So just making sure There are two hydrogens here, and there are two hydrogens here. I'm going to add those up. That's a total of 4 hydrogens. There are no hydrogens here, but there are only 2 here. So I'm going to place a 2 right here, and that would give me 2 times 2. That's 4 hydrogens. Now, I do need to check the oxygens. Okay, so the number of oxygens here on the reactant side, that's what we're going to check now. All right, so let's check those oxygens. There are 2 oxygens right here, and 2 times 3, that's 6. So that's 2 and 6. That's a total of 8 oxygens on the reactant side. On the product side, there are 6 oxygens here plus 2. So that's a total of 8. So it looks like the oxygens are balanced as well. All right, so what we're going to do is we're going to scroll this little baby on up, and then we're going to keep on moving. So here we go, problem number 10. Problem number 10 is a combustion reaction yet again. And so if you recall, just like problem number 2, problem number 10, we're going to balance in a particular order, and that is carbons, hydrogens, then oxygens, CHO, 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 CHO. We're going to balance it in that order. Okay, so here we go. There are 3 carbons on the reactant side. There is 1 carbon on the product side. So I'm going to place a 3 right here to balance the carbons. There are 6 hydrogens on the reactant side, and there are 2 hydrogens on the product side. So I'm going to place a 3 right here to give me 3 times 2, that's 6 hydrogens. Now I need to balance the oxygens. So what we're going to do is we're going to count the number of oxygens on the product side. That's 3 times 2, that's 6. Plus 3 times 1, that's 3. That equals 9 oxygens. Well, right here, there's 1 oxygen in this formula, and I have to account for that. So 1 plus what number is equal to 9? So I'm going to solve for x on this. So that will be x is equal to 8. That means I need 8 oxygens just right here. What number gives me 8 oxygens? That would be a 4. So it's 4 times 2, that's 8. Plus this 1, that's 9 oxygens. 3 times 2, that's 6. Plus this 3 times 1, that's total of 9 oxygens. Bammo, that one is balanced. You probably need to watch that one again just to make sure and see how that went. When we have an oxygen in this other formula, unlike on problem number 2, we do need to account for that. All right, we'll have another example of that here in just a bit that we'll have to account for. So we'll check that out in just a bit. This next reaction, number 11, is a combination reaction whereby calcium plus oxygen gives me calcium oxide. 1 calcium on the reactant side, 1 calcium on the product side. They are balanced. 2 oxygens on the reactant side, 1 oxygen on the product side. They are not balanced. So I'm going to place a 2 in front of the calcium oxide on the product side. That will give me 2 oxygens, and in addition to that, 2 calcium. So I'm going to have to place a 2 in front of the calcium here. And now that one is balanced. Perfect. All right, so problem number 12. Problem number 12 is also a combustion reaction. Again, combustion reactions, I have some carbon, hydrogen, oxygen, or combination thereof, plus molecular oxygen, that's right here, produces carbon dioxide and water. This is a complete combustion reaction. We always balance it in this order: carbons, hydrogens, and oxygens. So let's get started on this one. So there are 2 carbons on the reactant side, and now there will be 2 carbons on the product side. There are 5 plus 1. 5 plus 1 hydrogen. That's a total of 6 hydrogens on the reactant side. There are 2, so I'm going to place a 3 right in front of the water to give me 6 hydrogens. Now I'm going to count the oxygens like I've done before. I'm going to count these oxygens. That's 2 times 2, that's 4 oxygens, plus 3 times 1, that's 3. So that's a total of 7. That's 4 plus 3. That's 7 oxygens on the product side. Now, just like what we did on problem number 10, there's 1 oxygen here. So what we're going to do is we're going to do 1, that 1 oxygen plus X, that X is going to go here, is equal to 7. Okay, I'm going to solve for X. X is equal to 6. I need there to be 6 oxygens right here, plus that 1 will give me the 7 that I have. So what number do I place here to give me 6 oxygens? That's correct. That will be a 3. So 3 times 2, that's 6, plus the 1, that is 7. And there are already 7 oxygens, just like what we counted up before. Okay, perfect. So let's move on to problem number 13. Problem number 13, this is a most famous reverse of a very famous reaction, the Fitz-Haber process of production of ammonia. But this one is taking ammonia and decomposing it. So ammonia decomposing to nitrogen gas and hydrogen gas. What we're going to do is look at this complicated formula. There's 1 nitrogen on the reactant side and 2 on the product side with this 2 right here. Perfect, beautiful. So that means that the nitrogens are not balanced. In addition to that, there are 3 hydrogens on the reactant side and 2 on the product side. So maybe initially one might place a 2 right over here to balance up the nitrogens. And that might be perfectly fine. But we do have to deal with these hydrogens, and there are 3 on the reactant side and 2 on the product side initially without this 2 coefficient. So the greatest common factor between 3 and 2, or 2 and 3, is 6. So I need 6 hydrogens on both sides. That would give me a 3 right here and a 2 right here. And so that gives me 6 hydrogens on the product side, that's 3 times 2, and 6 hydrogens on the reactant side, that's 2 times 3. 2 nitrogens and 2 nitrogens. Looks like that one is balanced. Perfect. All right. Looking great. The next one, which is number 14, is also a combustion reaction here. Okay, again, a complete combustion, and you balance these always in this same order. That's C, H, and an O. How many carbons on the reactant side? 4. How many on the product side? 1. So I'm going to place a 4 coefficient in front of the carbon dioxide. How many hydrogens on the reactant side? So be careful with this because there's 9 plus the 1. That gives me 10 hydrogens. So that means I'm going to place a 5 in front of the water. That's 5 times 2. That's 10 hydrogens. Now I'm going to count the oxygens, of which are right here. That's 4 times 2, that's 8, plus 5 times 1, that's 5. I'm going to sum up these numbers. That gives me the lucky number 13. And oh, by the way, that is a lucky number. So now what we need to do is we need to look at this oxygen right here. There's 1 oxygen here in this, and that's 1, plus what number is equal to 13? So I'm going to solve for X. That equals 12. So I want 12 oxygens to be here. That would be a 6. And that would be 6 times 2. That is 12. Plus 1. That's 13 oxygens. And there are 13 oxygens on the product side for that combustion reaction. I think we nailed that. All right, so let's slide this on down here some more so that we can do some more problems. Fantastic. Get this completely set up here. All right, awesome. Let's do number 15. This is a decomposition reaction where you have nickel chlorate decomposing to Nicholas chloride and molecular oxygen. So hopefully, obviously, this is the most complicated formula. That's a Nicholas or nickel 2 chlorate. Okay, and so there's 1 nickel on the reactant side, 1 on the product side. There are 2 chlorines on the reactant side. There's 2 chlorines on the product side. There are 2 times 3, that's 6 oxygens on the reactant side, and there's 2, so I need there to be 3 oxygens on the product side. And now that one is balanced. That one was pretty simple. Okay. All right, fantastic. Let's do the next problem here, and that is aluminum plus oxygen. This is a combination reaction, produces aluminum oxide. So just before we finish up that problem, we are well, rather, we are watching on YouTube me, which is you, and I am the Crazy Hat Chemist. So this video is sponsored by none other than yours truly, that is myself, the Crazy Hat Chemist. So please like and subscribe and watch the rest of the videos here. I got some fantastic videos. I even have some cooking videos. So check out some of those cooking videos if you want to learn how to do some great cooking. All right. So let's continue with problem number 16. We have 1 aluminum on the reactant side and 2 aluminums on the product side. So I'm going to first place a 2 in front of that aluminum right there. That would give me 2 aluminums on both the reactant and product side. Then there are 3 oxygens on the product side and 2 oxygens on the reactant side. So the greatest common factor between the 3 and the 2 is a 6. So I'm going to place a 3 here and a 2 here. Now that's 6 oxygens on the reactant side and 6 oxygens on the product side. But now I've unbalanced the aluminums that I had balanced before. That's why I did that in pencil. If you noticed, I put a 2 coefficient in front of the aluminum. And what does it need? 2 times 2, that's 4. I need a 4 coefficient, and now it's balanced. Fantastic. We got 3 more problems to do. We have chromium plus oxygen yields chromic oxide. This is a combination reaction, just like number 16 was a combination reaction. And again, what we want to do is we want to start off with the most complicated formula, which is on this product side here. There's 1 chromium on the reactant side, 2 on the product side. Now, I'm not sure if you're noticing this, but 16 and 17 are really, really similar. If we just balance the oxygens first, then we're going to rebalance the chromiums in just a moment anyway. So the greatest common factor between 2 and 3, that's a 6. So I'm going to place a 3 here. That will give me 6 oxygens, and a 2 right here. That will give me 2 times 3, 6 oxygens. There are 4 chromiums, and that's why that 4 belongs there. Okay, hopefully that worked for you. That's number 17. Number 18, we have aluminum nitrate plus sodium hydroxide produces aluminum hydroxide and sodium nitrate. Okay, this is a double displacement reaction. Where to start? I would start with the most complicated formula with the most unusual elements, and that's, doesn't really matter. But 1 aluminum, 1 aluminum, 1 sodium, 1 sodium. Now let's check out the nitrogens. 3 nitrogens on the reactant side and 1 nitrogen on the product side. So I'm going to place a 3 right here. Now there are 3 sodiums, which I already balanced. So that means that I need to have 3 sodiums here on this reactant side. Now let's count up the oxygens. So 3 times 3, that's 9, plus 3 times 1, that's 3. That's a total of 12. 3 times 1, that's 3. 3 times 3, that's 9. That's a total of 12, and they are equal. Fantastic. And that one is balanced. Perfect. Number 19, our final problem here, folks, that we're going to balance, and this is a decomposition reaction. This is potassium chlorate, produces potassium chloride and oxygen. 1 potassium on the reactant side, 1 on the product side. 1 chlorine on the reactant side, 1 chlorine on the product side. The oxygens are not balanced, and I'll highlight those for you. There's 3 on the reactant side and 2 on the product side, and we have been here before with problems similar to this, We're going to use the greatest common factor, which is a 6. So that's 3 times 2, 6, and 2 times 3, that's 6 oxygens on both the product and the reactant side. Now there are 2 potassiums and 2 chlorines on the reactant side. So I need there to be 2 potassiums and 2 chlorines on the products. So 2 potassiums, 2 chlorines on the reactant side, and 2 potassiums, 2 chlorines on the product side. And that is it, folks. You're watching The Crazy Hat Chemist. That's right. And oh, yeah, check out that weight. 1,000 grams right there. That's 1,000 grams. That's 1 kilogram. It's 1 kilogram of The Crazy Hat Chemist. That's what that is. I hope you enjoyed watching this video, and I hope you have a fantastic day. Please watch more and like and subscribe, and I love you a lot. Talk to you for next time. Bye for now.